Now we are in assignment 3, loop structures. We will be doing this assignment in R Markdown. R Markdown is a file format for making dynamic documents with R. An R Markdown document is written in Markdown and easy to write plain text format, and it contains chunks of embedded R code. R Markdown is basically used for creating templates, reports, etc. You can create an R Markdown file by going into the file at the top and then open a new file. You will see the option of Markdown here. Click on it and you will be asked to mention the title. Now for output, you have various options. We will be using HTML output for all our assignments. You select it and there you go, you are in R Markdown now. You can write your code here now. Now if you see at the top, it mentions the title, author, date, output. So here you have an option to use either the default theme or you can go on internet and find a different theme. They are available on internet for free. You can search for a theme and then copy the theme and paste it in the output as I have shown here. I am using the architect theme here. You can either use the same theme or you can find any other theme on the internet. Now below the theme you can see the white blank space. Here you can write anything and it will not be executed by the console. So you can use this space to write the report text. Now as shown here, the formatting is pretty simple. If you want to make the text bold, put the text between the two asterisks. If you want to italicize it, put it between one asterisk. You can create a bullet by putting a dash before your sentence, and so on. You can find more about formatting on internet. It's pretty straightforward. Now next we have the highlighted portion here. This highlighted portion here is called the chunks. This is where you write your code. To create a chunk, you write 3 acutes, which is next to one number key in your keyboard. Then open a bracket and write the letter R. Then you can even name the chunk as I named it data here, or you can close the bracket without naming it. Now in this chunk you can write your code and it works similar to the code window that we saw earlier in RStudio. Now press enter and close the chunk by writing 3 acutes again. Your code chunk is created. Now once you are done with the code, you go to the knit button here and click on it to create the final HTML document. So let's first complete our assignment here and then we will knit it to create a final HTML document for our assignment 3. Okay, as you can see under the synopsis, I have given a brief about the assignment. In this assignment, we will go through various concepts that require looping through the dataset empty cars. This data empty cars is available in R itself, so we don't have to read it in the form of CSV file. Now we will create our first code chunk. First we will load the data and store it in a variable called cars. Next step is to check the basic structure using str function and check the summary of our data. These two steps are general steps and we will do it in almost all our assignments. This will help us understand the data better. We can run these two commands by selecting them one by one. Now as you can see, the output of the structure shows various variables, their classes and few observations associated with it. We have variables like mpg, cyl cylinder, displacement, hp horsepower, etc. Similarly, we can see more information about the data using the summary function. Now this output window which is popping out is a temporary window. We can close it after checking our output. Although our final output will be printed in the HTML file, but running each chunk enables us to see if our code is running properly or not. Now let's close this window. Okay, so going forward, I have divided the assignments into different questions to make it more understandable. So our first question given here is, use a for loop, create a new vector called HP underscore WT underscore ratio, which is HP weight ratio, that has one entry per observation, that is one entry per car. And the entry is the ratio of HP to weight, that is HP divided by weight. So we will first create our code chunk. And then we will create an empty vector equal to number of rows of our data frame cars. We will use for loop to divide HP to weight and it will run 32 times equal to number of rows of our dataset. So to initiate the for loop, we will write for, open the brackets and write I in 1:32. I is called as counter and this means loop will run from 1 to 32. We will open the brackets to initiate the loop. This is the loop body where calculation will take place. Here our task is to divide the HP value by weight of each car and then store it in HP weight ratio vector that we had created earlier. So we will write HP weight ratio square bracket I, then car square bracket I4. This means when I will be 1, it will return the value of first row and fourth column of our cars dataset, that is HP value for first row. Similarly, cars square bracket I6 will return the value of first row and sixth column, that is weight variable. And as shown above, I will take the value from 1 to 32, performing this calculation for each row and storing it in our vector HP weight ratio. Then we will close the bracket and print the values of our output. After it, we will put 3 acutes and close the chunk. This is how we write for loop. We can run this and we will get our output at the bottom. Now the second question requires us to use a while loop. Create a new vector called FCYL that contains the names of the cars that exactly have 4 cylinders. So let's create a chunk for while loop. First, we will create 3 variables that we would need in a while loop. We can give it any name. I am using these names. We will initiate these variables by assigning them a random value of 1, 1 and 0. Now let's use the while loop. While loop is basically a while and a if loop. If loop only comes into picture if the condition given in while is true. So in our case, while loop will run until CYL, that is cylinder, is less than equal to number of row of cars. Next, we will open the bracket and write the if loop. We will write cars within square brackets CYL, comma 2 equals to 4. If you put a single equal to sign, it means it will assign the variable that value. If you want to check equality, you need to put 2 equal to signs. Okay, so now open the bracket, store the name of the car in the variable FCYL that we created above, and then increment the counter C by 1. And then exit the loop and increment the counter CYL by 1. And then close the while loop. Now if you see, I have given the explanation here. You will find such explanation in almost all the assignments after any complicated code. So let's see what is the explanation given here. We will enter into while loop. While loop will run until we reach the value equal to number of rows of cars dataset, that is 32. In while loop, we provided a condition up to what value while should run. Here we have given CYL value should be less than equal to n row cars. That means CYL will take values from 1 to 32. Then we move to if statement, which subsets each row and second column from the car data frame and checks if it is equal to 4. This is the column that has number of cylinders. Let's say the car mentioned in the first row and second column of our cars dataset has the cylinders equal to 4. Then if loop will store the name of the car, which is given by the row name of our dataset, into a variable called FCYL. This is the variable we had created earlier in the beginning. As you can see here, we have a counter C with our variable. We are using it to store the name of the cars in our variable starting from FCYL1 for first step, FCYL2 for second step, and so on. It is like an index for our variable. So we will increment this C by 1. Then close the if loop and increment CYL by 1. Then again check the condition given in while loop if CYL is less than number of rows of cars, and then keep on performing the same operation until the condition of while loop is violated. That is when CYL value becomes more than 32. So that is how while loop works. Now let's move on to the third question. Here it says use a for loop to find the sum of all the values in the qsec variable and put the final answer in variable called qsec total. So first we will initiate a variable called qsec total. We will use this variable to store the results. Hence we will assign it a value of 0. Then we will use for loop from 1 to 32. Now when I will be equal to 1, the loop will subset the first row of the 7th column of our cars dataset. This column has the QSEC values. And then we will add it to QSEC total variable, which has the value of 0 in the first step. And then store it in the QSEC total itself. So what will happen here? Let's say the value of first row 7th column is 10. So 10 will be added to QSEC total, which is 0, and hence 10 plus 0 is 10. Now this 10 will be stored in QSEC total, replacing the 0. So next time when we will add QSEC total, then 10 will be added. Now in the next step, when I will be equal to 2, we will subset the second row of 7th column of our dataset. Let's say the value is 20. Now our loop will add it to QSEC total. Now QSEC total is already 10, so 20 plus 10 will be 30, and then again store it in QSEC total. So the new value of QSEC total will become 30 now. And this process will continue until our counter reaches a value of 32. That is the number of rows. This way we will be able to add all the values of the column. And then finally we will print the result. So that is how you can add the entire column using the for loop. Now moving to the question 4. Question 4 is asking us to find the sum of all columns, that is one sum for each column, which are non-integer values. So here we will use an interesting function called sapply. This is also a loop function belonging to the family of apply function, but it is quite fast and efficient. Now the question is asking us to sum the non-integer columns. So to identify the non-integer columns, we can check the structure of the data frame. We will come to know that MTG, displacement, DRAD, WT, QSEC are non-integer columns. We will now use sapply to sum these columns. To use sapply, we can simply write sapply and give the input columns, which are 1, 3, 5, 6 and 7, and then mention what function we wish to apply on these columns. This way we will by default apply the function column-wise. The good part of sapply is you can either use the default function or you can even write your own function here. As we need to do the sum here, so we will use the default sum function. We will run this and we will get the sum of all these columns. So you can see how quickly we are able to find the sum of all these columns using sapply. Another good feature of sapply is the first argument of sapply is a list. So it can take data that has different classes. Here you can see there is a small note here. Point 1. There is one more function called lapply, which is similar to sapply, but the output of lapply is always a list. However, sapply gives the output as vector or matrix. Now based on our requirement, we can use sapply or lapply. Point number 2 is another function is apply, which has the same first argument as the above, but the second argument is either 1 or 2, which is basically row or column. So whether we want to do column-wise sum or row-wise sum, we can mention here. Once we specify 1 or 2, then the third argument is the function such as sum, mean, etc. You can use the apply function for the above problem as shown here. It is quite simple. Now there is another powerful function called tapply. It is used to apply a function on a subset of a vector, and that subset is a factor. For example, we have MPG values in our dataset, and we also have cylinder values as 4, 6 or 8 cylinders. So if I want to know the average MPG cylinder wise, then I can use tapply very easily as shown here. The first argument of tapply will be the column from which we want the value, and second argument is the index, basically the basis on which we want to filter the first column, and third is the function. We are using mean function here. Run this and you will get the mean value of MPG for 4, 6 and 8 cylinder. With this, we will be concluding our assignment. We have learned for loop, while loop and family of apply functions. I hope you were able to understand these concepts. You can do more on these concepts by going through various examples given on internet. And yes, we will reinforce these concepts as we move along the course. Now that we have completed our assignment, we will knit the file to produce an HTML output. To create an HTML output, go to knit and just press it. It will take some time to process it. And then finally it will create our output in a nice formatted way. And here it is, our output in a nice formatted way. You can scroll through it and even format it further as per your need. That's how you create an R Markdown file. So now on for a better comprehension, I will be explaining all the assignment in the already created HTML output files. So that is all from this video. I'll catch you up in the next video. Have a great time. See you.